Greetings, I'm Scarlett here, and today we are going to review for our test. So you'll see that each problem has an LT 1, 2, or 3, so you know what learning target it is. So you can fast forward to a learning target that maybe you need a little more help with. So we're going to start off with learning target 1, which is about domain and range. So you're going to be given pictures or a table of points or a set of points, and you're going to have to figure out what the domain and range is. So remember, domain is always left and right, and range is up and down. Supposed to be a D. Okay, so when I'm looking for my domain and I have a graph, if it doesn't go forever and always, I usually find the leftmost point, that would be -3, 0, and the rightmost point, and this would be 1, -4, and that tells me the x's, the left and right, tells me what my lowest x value is and what my highest x value is. And then I can write my domain. And when it's a graph like this that stops, we're going to write it as an inequality. So I'm going to say that x is between -3 and 1. You could also, another way to write it would be x is greater than, 3. Let me go back here because this is a closed circle, so I need to put a line there. Open circle, I don't need to put a line there because that doesn't include that -3. Or so you could say, you could split this up into two inequalities, and you could say, and, because both of them have to be true, x is less than or equal to 1. So that's the domain. For range, I look for the high point and the low point. And I notice that these are both the high points, but it says it can't equal 0 here for y, but it can here. So I'm going to use this for my high point, and then my low point, same thing right here. So I know that here's my y's. So I'm going to say the range, which is my y's. Y is between, and this time it can be equal to both of them, 0 and -4, because those are my y values at the high and low. So I look at my x values at my left and my right most points, and my y values at my lowest point and my highest point. All right, now on to a set of points. So the domain, remember, we write with braces. We say the domain is, and then we just list all our x's and we put them in order with commas in between them. So these are my possible x values, and then my range is my possible y values. So it looks like -4, 0, -4, 0, and since 5 is listed twice, I don't need to list it twice, I just need to list it once because it's the same in both of those. So that's how you do it with a set of points. And then here's a graph with arrows. So we see that it goes for domain, right? I'm going left and right. It's going left forever and right forever. So my domain would be all real numbers because there's no value of x that it can't be. My range goes up forever and down forever. I notice it goes up forever starting right here. That point is 0, 0, but it doesn't go down forever. So it's just, I'd look at my y value, it's just the numbers greater than or equal to 0 because 0 was the lowest point. So I say my range is greater than or equal to 0. All right, one more learning target 1. When I have a line that's not vertical or horizontal, it goes left forever and right forever. It goes up forever and down forever. So that means these are all real numbers. All real numbers for both of them. Okay, on to learning target 2. Learning target 2 had 3 parts. You had to write, you had to identify, and you had to evaluate. So we're going to start with the writing the identifying kind of first. So you need to be able to look at a list of linear equations and be able to tell or equations or functions and tell if they're linear or not. So remember, it had to be in the form y equals mx plus b. So that means y equals 3x would work, y equals -1/2 x plus 2. Sometimes you might see it like y minus 2 equals 3 times x plus 4. Anything where there's a y and an x and there's no squareds or square roots or absolute values. So those are examples of linear functions. Some functions that are not linear would be like y equals x squared, y equals the absolute value of x plus 2, y equals 3x cubed plus 2x squared, y equals the square root of x minus 4. Those are functions, but they're not linear functions. So part of learning target 2 is that you can tell whether it's a linear function or not a linear function. Okay, on to evaluating. Evaluating, you're going to be given a function, and then you're asked to find f of -5. Well, that means you take that number, whatever you're finding f of, and you plug it in for here, at any time you see an x in that function. So f of negative 5 is going to be 2 times negative 5, because I take out the x and put in the negative 5, minus 11. Well, 2 times negative 5 is negative 10, and if I subtract 11 from negative 10, I get negative 21. Watch your negatives there. I know some people aren't really good at that. If you have to use your calculator, use it, because it might be better to use it than to get it wrong. At least I would agree with that. Okay, another evaluating one. We'll zoom in a little bit. So now I'm evaluating f of 100. That means I'm going to put my 100 in for those guys right there. So it's 3/5 times 100 minus 40. Again, if you need to use your calculator, go for it. 5 goes into 100 20 times. 3 times 20 is 60. And 60 minus 40 is 20. So f of 100 is 20. Okay, the last part of Learning Target 2 is being able to write a linear model. So we're going to write a linear function for this set of table, for this set of points. And what I like to do is find the distance. So it's kind of like slope. Find the distance. That's a positive 2, increase of positive 2. So each one of those is increasing 2 each time. And this one is increasing 6, it looks like. How about this one? Wait a minute. That's 2. That's not, yeah, that's 2. So that's not 6. That's the problem. That's 10. That's an increase of 10. And here's 10, and here's 10, and here's 10. I was confused for a minute because I thought it was different. It can't be different for it to be linear because it's a constant rate of change. So my slope then is this y distance over this x distance. So my slope is 10 over 2. So there's 2 things I need to write a linear model. I need the slope, 10 divided by 2 is 5, and then I need a y-intercept. Well, the y-intercept would come in right between this distance right here. What would it be? Well, these are 2 apart, so that in the middle would be 0. And then I figure out what's in the middle of these 2. Well, since they're 10 apart, I would go 5 from this one. So I'd either add 5 to this or subtract 5 to that. So I'd get 17. And then that, just figuring out what the distance is between there, where the 0 is, that helps you find it. Because remember, the y-intercept happens whenever x is 0. So you've got to find the x equals 0 spot. So I would say plus 17. In this one, I leave a blank there so you can kind of see what's happening. This one's a little more challenging. So this is 1 apart, right? Up 1. This is down 3. So my slope, I'm thinking, is negative 3 over 1. And then I can always test this too. This is up 2, and this is down 6. And negative 6 over 2 is also negative 3. So I know I have a y equals negative 3x plus something, but I don't know what. But this relationship right here, this slope, tells me that for every 1 I go up, I go down 3. So I know I could go up 3 more here, then I would have to go up 3 times 3 here, down 3 times 3. But I see the 1 and I see the 3, and I know if I just go 1 over this way, I'm going to get to my 0. You could list them all out if you wanted to, and just say, okay, at negative 2, I would subtract 3 here, so that would be 7, and at negative 1, I would subtract 3 more, so that would be 4, and at 0, I would subtract 3 more, and that would be 1. Or you could come back this way and say, oh, well, what if I subtracted 1 here, then I would have to add 3 here. What's 3 plus negative 2? It's 1. So it doesn't matter if you come from the left or the right. You can still get it, and then I just put a plus 1. So you can figure it out if you just take the time to do it and know that the slope means how many you're going up for each one you go up here when you reduce that slope. Alrighty, on to Learning Target 3, which is to graph and find the domain and range. So remember, the easiest way to graph, you can use a table anytime you want to graph, but the easiest way to graph is to know that that's the y-intercept and that's the slope. So I'm going to graph my y-intercept first, and then I'm going to use my slope to find more points. So when I have a negative 1/4, that means I can go down because it's negative and right because that's positive. So I'm going to go down 1, right 4, or I could have switched and gone up 1 and over 4 and to the left 2. So here's my line. I graphed it. And remember, a line that's slanted, the domain and range are always all real numbers because it goes left forever, right forever, up forever, down forever. Okay, so this graph is an absolute value graph, I can tell, because of little absolute value signs. And remember, it's always important to notice what it's going to be like. So after you're done graphing, if you use points or whatever you use, you can just say, oh, yeah, that's a V. Because if it's a line, then you know you did something wrong. So I'm going to show you how to use a table, but then I'm also going to remind you that this is the slope, h and k are 0, 0, so we could just go to 0, 0, down to over 1, and we'd have it. But if you want to use this table, I'll show you on this one how to use the table. So whatever makes the inside, whatever value of x makes the inside of the absolute value 0, that's what I start with. And since it's nothing but an x, it's 0. And when I put a 0 in there, the absolute value of 0 is 0, and times by -2 is -2. And then I would choose points to the left and to the right of that. When I put a -1 in, I get negative. I'm sorry. I thought I said 0. Sorry, 0 times -2 is 0. If I put a -1 in, I get a -2. If I put a -2 in, that's 2 times -2, I get a -4. Same thing happens down here. I get those points. So then I can graph those points and connect the dots. And then it asks what's the axis of symmetry. The axis of symmetry is x equals h, you might remember, but it's this line that goes right there. That's x equals 0. It asks what the vertex is. That's 0, 0. And it asks what the domain and range is. Well, the domain, again, because it goes all to the left forever and to the right forever, is all real numbers. And then the range starts here and goes down, so it starts at 0, 0. So the range is y is less than or equal to 0. Alrighty. On this one, we just have to find the rate of change for a certain interval. So it looks like we're going from here on up to somewhere over there. But remember, the slope is this opposite on each side. So I look for the slope. It looks like this is a distance of 2. So if I go up 1 and over 2, it looks like my slope is 1/2, negative 1/2 on this side. So it must be positive 1/2 on this side. So go up 1 because this is 1, and over 2 because that's counting by 2's there. So I know it's 1/2 in that interval. If they had given me this side, it would be negative 1/2. Okay, on to piecewise functions. Your favorite. So we're going to always mark our little line right there to tell us, okay, we graph this one to the left of that line and this one to the right of that line. So first we're going to start with this one, and it says negative x. That means if I'm graphing negative x, because that's my f of x, whatever x is, it's the opposite of it. Oops, I shouldn't have started at 0 because we're not supposed to start at anything. We're supposed to start at -2, so my apologies. Let's start at where we're supposed to start, -2. Some people like to just graph the whole thing and then erase the part they want. That's fine too. So what's the opposite of -2? 2. Okay, so how about -3? What's the opposite of -3? 3. What's the opposite of -4? 4. Knowing that it's an open circle, that one's going to be an open circle. So I go to -2, 2. So I'm right on the line and I put an open circle. And then I go to -3, 3, -4, 4. And I have a line that goes like that. And then I'm going to graph the other function. Now the other function, since the y-intercept is in play, I'm just going to graph my y-intercept. And then I'm going to go up 2 and over 5. Now I know it goes like this, but I have to figure out what happens to it on that line. So I'm going to put -2 in there. So I get -2 times 2/5 plus 4. Well, -2 times 2 is -4. So I have -4/5 plus 4 is 3 1/5. So I know when I'm over here I'm up 3, and then I'm up just a little bit more. And you could just connect the ruler and where it crosses that little dashed line too. So that is our graph of that piecewise function. So we're going to figure out what intervals we decrease and increase. So we always go from left to right, remember. So if I hit this line, I'm going to be going up, so it's increasing on this side, and then I'm going to go down, so it's decreasing on that side. So here's -4, and it's always an x value. So when x is less than -4, I'm increasing, and when x is greater than -4, I'm decreasing. So it's just a matter of left to right is going up or down, and then looking at the x value so you know what to put on your interval. It'll always be x is less than something and x is greater than something. Now we get to write a piecewise function. So remember, it always has an f of x. It always has one of these things. We have two different things going on. I like to notice where this little line is. So that line is at 2. So I see that for the one on the left of 2, it's an open circle, so I'm going to say less than 2. For the one on the right, it's a closed circle, so I can say it's greater than or equal to 2. And then I just need the equation of the lines. So I look for the y-intercept. This one on the left has a y-intercept of 1, and the slope is 1, 2, 3, 4, 5, 5 halves. So then it's 5 halves x plus 1, because all I need is the slope with an x, and then plus or minus the y-intercept. So over here, I don't see the y-intercept, so I have to find it. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. That's a 6 over 4, which reduces to 3 halves. So I keep going, 1, 2, 3 over 2. So I use my slope to find the y-intercept. Looks like it would have been 8. So my slope is 3 halves, and my y-intercept is 8. And so the equation of that line is 3 halves x plus 8. And then I've written the function. So make sure you have all those parts. Make sure you don't forget the domain part, the function part, and the little brace and everything, because you need all of those parts. Okay, this is Learning Shortcut 8, where we get to compare our absolute values. We are almost done with our review. So this is what I'm comparing it to. A is bigger than 1. So that means that this function compared to that is a little skinnier. We call that stretched vertically. And it's a scale factor of 2. So we've stretched vertically. Our scale factor is 2. Whatever the slope is our scale factor. Alrighty, this one. This is negative, so it tells us it's reflected over x, the x-axis. And this tells us that we're up 7. This one right here says we are left 8. Remember, it's always the opposite of what you think. And then we are down -3. And here we have to graph it, so we get our, we know it's down 6 and left 2. So our vertex is -2, -6. So we graph that first. 1, 2, 3, 4, 5, 6. This is the way to do it without a table. We know our slope is 1/2, so we go up 1 over 2 on both sides, and we connect the dots. And we have graphed it. Okay, same thing over here. We know our vertex is 3, 8. So we go over 3 and up 8. And then we are going to use our slope. It's upside down. That tells us it's upside down. So we're going to go down 4 and over 1, down 4 and over 1. And we can keep doing that a couple times, and then we just connect the dots. And then our review is all done. So I hope that you study hard for the test. Good luck for it with your studying. M2, signing out.